Hello, today's topic will be on work, power, and energy. So let's get right into it. So this is a practice worksheet which we'll be solving together right after we do the explanation. So this is best done after you learn force is equal to mass times acceleration. This is something you will be needing because if you don't know force, then you won't be able to do work and you need the force. So look at our other YouTube videos to find out what is force if you haven't done that already. If you have, we can get right into it. So what is gravitational potential energy and why is it measured in joules? So joules is a fundamental energy SI unit. So let's just start up when is potential energy used? This is the ground. This is a table you have. This is a box. So on that table, and the box is bigger than the table. It doesn't have to be, but it is because I'm not very good at drawing. So this box is going to be 1 kg. Let's just zoom in. 1 kg, and it's going to be 1 meters. And of course, since this is our what do you call MYP, gravitational acceleration is equal to meters a second squared. When you go into IV, you'll find that gravity should not be taken as 10 meters a second squared, but because of your MYP, we take nice simple round numbers of 10 meters a second squared. Yeah, so it'll be 1 kg times 1 meter times 10, so that would be just 1 into 10, which is equal to 10, and this is going to be 10 joules. Right, and next on we have work. So work is force times displacement. So let's have the ground again. There's a block on top of it. It moves 1 meter. And to move it 1 meter, we need to apply a constant force of 10 newtons. So we just do 10 into 1, and then we get 10 as well. So this is going to be newtons times meters, and that will be Newton meters. We can also write the same thing as 10 joules. They're the same unit, different words, but they mean the same thing. Different letters, they mean the same thing. Let's move on to the next one. Next we have power. Kinetic energy is special, by the way. We don't actually need to memorize this. It's a good idea to have this formula because it helps with the understanding. There are no direct questions. This paper does not have any direct questions. Your exam will most probably also not have it. So let's look at power. So what is power? Power is just an extension of our work. So it's the amount of work you do over the time. So how long did it take? So if I move this block and it took me 1 second, then there is no difference. Work will be equal to what do you call power, because it'll just be 10 times, it'll just be 10 over 1, which is 10. Dividing by 1 has no issue. If it took me 2 seconds, if it took me 2 seconds instead, it would be 10 over 2, which would be 5, which is less because it's division, so it will be inversely proportional. So we know power, so time is inversely proportional to power. If you increase time, power will go down. If you increase power, then time should go down. Yeah, so let's look into the questions. First question, very simple, basic, gives you force, it gives you displacement, you multiply them together, you get joules, which is your work. When you do this, your standard physics, how you do your formula, so write the formula, what do you call it, substitute the numbers into that formula, then give your final answer with the unit, SI unit. You don't have to write joules, like you don't have to write the full joules, just write the simplified, which would be capital J. Uh, Moving on, question number 2, it's the same thing, just other way around. So instead of giving you force displacement, asking you for work, they give you work and they expect you to calculate displacement, which is easy because you just do division, rearrange the formula, it's perfectly fine, easy. Let's move on. We have here a block is being pushed by 5 newtons and being pulled by 10 newtons on the other side. Uh, as you can see, these forces are acting together, they're helping each other out, and if they're helping each other, you just add them together, and you can get the answer quick and easy. Other thing, opposite thing happening here for problem number 5, where the two are against each other. So this is pulling with 7, and this is pulling by 15 on the other side. So we do 15 minus 7 to give us our net force, and then our net force, which is going to be equal to 8. 8 times 6 is equal to 48, which is our work. Over here is a slightly more interesting one where they don't give you the second force, they give you one force. You know that the minusing, and you know the amount of energy it took as well as the displacement, so you just work it out. So you'd move this 5 from this side onto this side. When you do that, it becomes division, and now you can open the brackets because there's nothing else left. So it'll just be so from this you can quickly figure it out. Let me zoom in. This shouldn't be too hard. Question number 7. Question number 7 is the first question with a gravitational potential energy. So read the question. Right, we can see that it's given in 300 grams and 80 centimeters. Well, grams and centimeters aren't SI units, so first convert over your the units into SI units, so that would be zero point 0.3 kgs and zero point 0.8 meters. So zero point 0.8 meters is the same thing as 80 centimeters, same for the for the kg, right? And then from there you can quickly find the work. Next we have this one here, which is a nice question because it'll gives you force, gives you displacement, and it gives you time. And gives you time right here, right? So with this question we can see that there's no one formula which uses both force, displacement, as well as time. We can the way the question does it, I mean the way the answer screen shows it, is using the first formula for work and then taking the answer from your work and putting it into power. So first we calculate the work done, we take the work and we use it in the power formula. There is another way of doing this question. So first let me just explain it with this, right? So first we do our force times displacement to get our energy. Once we have our energy, we do energy divided by time to give our power, right? The other way of doing this would be to have one big formula. So we take work and we substitute it with F into S, right? So you have F into S over T, and then you can just solve the whole thing into one. So just do 450 into 3 over 6, and then that would be the same thing, right? But if you want to do it in one shot rather than having two formulas, but you would have to explain this just in a box at the side of the question stating what you did. Another thing is that we don't have to use the power formula just for work done by moving something. It can be any type of work and energy, right? So in this case it's energy dissipated by a lamp, so this would be heat and luminosity. Luminosity is another type of energy. It's energy by light, by photons. You don't really have to understand the fundamentals of why that energy exists or how it works. You just have to know that the lamp is giving out 3000 joules over a period of 2 minutes, and so we first convert 2 minutes into our SI units of 120 seconds. So just pretty simple, we just do 3000 over 120 to get 25 watts. So we can find out the power even though a lamp is not being moved, because the formula is perfectly fine because it's just any type of work, and work is energy, and we can use other types of things because we see that it's joules, and this is also given in joules. So even if they asked you a random energy form, you could always do it. Last question. Last question is great, and it illustrates why we have this as S and not as D. So S is not equal to D. This is displacement, this is distance covered. They're not the same. Don't confuse them. And the reason why this is that there's a student here. He has a box of 50 newtons. He moves it up the ramp and then back down. Well, how much work has he done? Absolutely none, because the box has gone from A and it has ended back up at A, and therefore there is no net movement. Its starting and end point is the same, therefore its displacement is the same, as in displacement is 0, and therefore any number times 0 is also equal to 0. So work is just 0. So I hope you understand work, power, and energy better now. Please don't get tricked by these sort of questions, like this last question, and I hope everything makes way more sense now.